Good morning. Welcome to, wow, can you believe it? It's like the last sprint of web. Only thing you have left is build weeks. Congratulations, it's been a long journey. All right, so authentication and testing this week. Today we talk about authentication, give a brief introduction to it, and we'll right off the bat tell you, we're gonna recommend that you don't implement your own authentication, but we do want you to get an idea of how it works, okay? Now, today we talk about authentication using cookies and something called sessions. Tomorrow, we give you an alternative to that by using something called a JSON Web Token and no sessions saved anywhere on the server. So by tomorrow, you're gonna have answers to a lot of questions that are gonna come up today. So if you ask anything about tokens, I'll probably just tell you, hey, wait until tomorrow so that we can, so you have a better idea of how to contrast both ways of handling authentication. So this week is also not about authorization. That's gonna be very, I would say, unique to your company. We might mention role-based authentication, which is a good way to start, but I mean authorization, but this is all about authentication. It is providing a way for the client to tell your API who they are. So establishing identity, not access. Okay. Okay. With that out of the way, what do we talk about today? Passwords. How do we store passwords safely? Probably going to mention a couple of services that you can use instead of rolling your own. What a session is, how to store sessions in memory or the database, a couple of libraries that we can use for that. And that's it. Other than that, is just the whole point of having authentic. What do you think is the, let me start by asking this question so that we're on the same page, right? It's a good idea to start thinking about this stuff earlier. So what is the purpose of authentication? Why do we even go through the process of creating a way for users to register and log in into our API? Why? Securing data. Okay, yes, I'll take that. That's it. So it's so that you can restrict access to some of the data. Without authentication, crackers wouldn't have a job. Yeah, that's true. That's what they make their money at. But in reality, is a way. The whole idea you do this is because you have some data, some resources, some information that you want to restrict access to. And sometimes it's as simple as you have to be logged in order to see it. Sometimes we have levels of that, and that's where authorization comes in, where you say, yeah, it's not only that you're logged in, you also need to be an admin, for instance, in order to see this part of this. Or you have to be on the sales team to see the sales data. Or human resources data is something that's well protected. If you want to see those salaries, you have to be on a department that can see those salaries. Okay. So that's the whole workflow. Today and tomorrow is going to be that. It's just a way for register, log in, and a way to restrict access to a resource. Okay. I'm going to move a little fast, so I'm going to get right down to business. There are different ways of handling authentication. More and more, I think companies are understanding that it is way too risky to store users' credentials. So we are delegating those, let's say, the responsibility, but also the risk. We're delegating the risk, outsourcing it, if you will, to third-party companies. You have Firebase Auth, you have Okta, I think it's Okta.com, maybe. You have Auth0, maybe that come too. You have Firebase Auth. They have authentication services. There are others. I'm gonna give you those three for just to get you started. This is what they do, right? The whole business bond, all of their engineers, all they do all day long is think about how to keep your identity and your authentication information secure. So that's all they do. If they get that wrong, they go out of business. The fact that they're still in business means they've been doing okay. Doesn't mean that you will not get a breach in your company. It's more of a matter of when you're gonna get breached. But it is a lot safer when you delegate that responsibility and that risk to a company that their whole team just thinks about security. So you have Okta, what we use here, Auth0. We're gonna come to this page tomorrow to see some stuff. And also you have Firebase authentication. So just do a search on identity as a service and you'll find a whole bunch of other services that do that. So take away, delegate the risk of authentication to someone else, but understand how it works. So how does it work? Well, we have to go back to think about HTTP again, a little bit, about what an HTTP message looks like. And I have this pre-made instead of, because remember, the iPad now, it's kind of flipping people's screen. I don't know why. So imagine that your HTTP message, the stuff that you send back and forward between the client and the server, that has an object. That's just an object. The red curly braces represents the whole object. And this object has inside another object for the headers. So here you have key value pairs for the headers, and then underneath you have key value pairs for the body. Normally you're gonna find that authentication stuff, anything related to authentication, like information about the cookie that, I'll tell you what a cookie is in a minute, but information that you need to exchange between the client and the server in order to keep that synchronization, in order for the server to know who you are, normally is stored in the headers. So the body will hold maybe the first time you connect to the server, like the client is gonna connect to the API. And the first time it does, and today we're talking about sessions, right? So the first time it does, it provides some credentials, username, password, whatever the credentials are. And then the API takes those and needs a way to remember about the client. Because HTTP by itself is not stateful, it's stateless, meaning there is no place where the client and the server can go and look at authentication information. There's no shared state between the two. So I want you to close your eyes for a minute and think of a scenario where you check into a hotel. When you check into the hotel, they used to give you keys. I think now they give you like a key card. So when you check into a hotel, you may get access to different amenities on the hotel. For sure, you probably have the room, right? But then you could get access to the sauna, to the gym, to the pool. They may have a casino. Like whatever it is that the hotel offers, the rest, if you go like places like my country, you have these resorts where they have different restaurants, you make reservations to go there. And all of that is connected to the account, to the identity of the guest, whoever is the guest of the hotel. But it all begins at the check-in. Well, on the reservation, yeah, but for authentication, it would be at the check-in. So you show up there, palm trees, you can feel the breeze, it's warm. It's not humid, it's just warm enough so that it's really nice for the white sands on the eastern side of the Dominican Republic, for instance, Punta Cana, Bávaro. And you're there and you hear the birds, and girls come to you with, you know, some champagne and stuff. Hey, you can get a drink. So you're there, and when you check in, you get a key card. That's what you get. You gave them a lot of money. In some places, they give you a wristband, and that's all you need. But you still get the key card to access the door in your hotel. So when you go onto your door will be closed. In order to open it and get into your room, you need the key card. At that point, though, the door is not going to ask you for your passport or for your driver's license or your ID. That already happened at check-in. So authentication is that process that happens. You have to think, every time you think authentication, I check in into a hotel, right? It's where I establish my identity with the hotel and I say, yes, I'm the one with the reservation. Here's my credit card. And then you get back something and they tell you, hold on to this wristband, hold on to this key card, because this is how you get access to the amenities on the hotel. Does that make sense? We're gonna give that key card a name today. We're gonna call it a cookie. I'm gonna wait until someone drops the Cookie Monster thing on Slack, because that always happens. I see a question there. So for our Build Week project, are we allowed to outsource authentication, as you mentioned? In fact, for your labs project, you're gonna get a scaffolding project that already has built-in authentication. You don't even have to worry about it. It just works. And it is done with Okta, third-party service, to show you, hey, here's how normally companies do it. They don't store stuff. So you're gonna get that. All right, now that we have the Cookie Monster things, what about Build Week? Now I don't know if your group is gonna get it, but we are also thinking of experimenting, giving Build Week's probably not this Build Week, giving Build Week scaffolding, but this week is about testing and authentication. So you will be building things that we see here. And again, 2 ways, one today, one tomorrow. You pick one and use that. Okay, but wait until tomorrow to make that decision, though, so that you see them both. All right, so now I want to go back to the hotel. It's nice there. Anyway, so that concept is what we call a cookie. And normally what happens is, and again, your API, right? Your client connects to your API, provides the credentials as you checking in, and then you get back that key card as a cookie. But also something that happens. Somewhere in their database, they activate your account. They'll be like, yep, he checked in, or they check in, they're ready to use the thing, and we gave them, like, you get a record on their database that says you're checked into the hotel, okay? Now, this information can be saved in different places. It could be on the database that you're using. It could be on something called, and this is by far the most common way of doing this. If you're doing sessions, it's probably you're storing in something called Redis or Memcached. Those are key value stores optimized for session information, really good. But if all you have is your database, you can still store sessions in your database. In fact, we're gonna do that today, okay? And if another client does the same thing, the process is still the same, only that each client, this is very important. I'm gonna make a pause for drama. Each client gets its own cookie and its own session, okay? So remember, the session is a row on a database somewhere. That's not the cookie. The cookie and the sessions are not the same thing. The cookie is like the key card. The session is the information they save on their database, okay? 2 things, but they work in tandem. Because the information that you store in the cookie is actually the ID of the record for the session. That's what goes into the cookie. Because when you check into the door and you go to the door and you provide your key card, what the door is gonna do is gonna connect to their database, and it's gonna take the ID out of that key card and check against the database to see, is this guest allowed into this door? Okay? So key card, the cookie, session is the record on a database. Just information saved on the database, on the server, okay? Not on the cookie. Great. So inside again, log in, the API is gonna validate the credentials, send back a cookie. Now, what happens when I say that you go to the room or to the, let's say to the gym, and you need to open the door using your key card, that's you going somewhere else to get some services. When you go to get some services, you need to provide the key card. You need the key card or the wristband, okay? This is how you say, this is who I am. So you show up as the client. Remember, each client gets a session. That means if I, as a user, log in into my phone and then log into my laptops, the API is gonna have 2 different sessions for the same user. Doesn't matter. It's not per user, it's per client. So being logged in to Firefox browser If you go open the same page on the same computer using another browser, you're not logged in. You have to log in on the other browser. They are considered two different clients. Okay, so you as a client come back and you want to access a restricted area. What do you need to provide? Your identity in the form of the cookie. And this cookie is going to have the session ID. That's the information inside the cookie. Cool. And of course, the API is going to validate that, yeah, in fact, that wristband is still valid before they let you go into the restricted area. So what is the responsibility of the server in all this? Well, validate the credentials, of course, create a session, produce a cookie, and then send back that cookie. That's the whole flow. That's what we're going to do today. And then the second part of that is when someone goes into a restricted area, we should check the validity of the cookie and make sure that the session that this cookie refers to, that record in the database, that session saved on the database is still good before providing access. That's the high level overview. The rest is just code. That's the easy part. Questions? Let's go do it. All right, so we're going to use a library for this, and the library is going to help us in the producing of the cookies, saving the sessions. All of that stuff is going to happen thanks to this library. There are quite a few of them. We're going to use one called Express Session. Okay, so here we go. Express Session. Spoiler alert, if you work through the project in the morning with me, the project in the afternoon is going to be done, which means you're going to have extra time to continue practicing those joins and the sequels and the foreign keys, and maybe build a small project. Maybe build this one from scratch. Okay. So Express Session is the library, but before we even attempt to deal with sessions and all that stuff, we need a way to store username and passwords, and the password should be not encrypted. Encrypted is a two-way process. You can decrypt a password. They must be hashed. So a library that is good for that, instead of calling it bhash, they call it bcrypt. It's kind of weird. We're going to use something called bcrypt.js. There's a bcrypt too. They're pretty similar in what they do. I picked this one because at some point, sometimes the other one gave me some errors. So we're using this one now. It's pretty popular, 750,000 downloads a week. So bcrypt.js is going to help us take the password and turn it into a jumbled string of characters so that it is safer. If any attacker goes into our database and grabs user credentials, the password is not visible. And that is important because some people, not you or me, of course, but some people will repeat passwords across different accounts. So if one of those places get compromised and they grab a hold of your password, they could potentially use that same password in other places. So to protect ourselves from that, we use a hashing algorithm, and you'll see what that hashing algorithm does because you're gonna do an exercise now. It's a simple exercise. So in the guided project, let's go to the API. Well, let's do it on the server itself because it's easier. And in here, is this good enough right there, the size? If not, let me know and I'll bump it up a little more. So in here, we're gonna do a server that, and we're gonna do a get to /hash. Well, when I say we, I mean you. I'm gonna go through the documentation, and here I'm gonna do rest.status and send back an object. This object is going to, this object is gonna have a property called password, and then another one called hash, okay? And what you're gonna do is you're gonna read a password property from the headers. And then you're gonna hash the password and send back both the password and the hash. So there is some searching into the documentation, and welcome to the life of a developer. 95% of your time is trying to figure out what to do, where to go to get the information, and reading documentation and reading other people's code. And then 5% of your time is going to be actually writing stuff. So we're going to take those 7 minutes to see if we could work through this exercise. And by we, I mean you. So your job is go read on the bcrypt.js library. See if you find a way to accept. You have to read the password. Remember, password property from the headers. You're going to read that. Take that password, hash it, produce a hash out of it, and then return back the password and the hash so that we see the differences. And we're going to take 7 minutes for that. So I'll see you back in 7 minutes. We have a guest. We have the Cookie Monster here.
Too short.
That's the actual Cookie Monster. All right, I'm getting errors on that code. Oh, let's copy another one. Let's try this one. Should work. Oh, illegal argument, undefined string. Ooh, weird. Why is that? What is working? What's going on? Don't have anything on the headers. That's right. All right, so let's take a look at this code. Well, the first part is I want to read from the headers. Here we are. So we're reading the password out of the rec that headers that password. Step one, done. Step two, we got to use the library to hash the passwords. And then we're going to send back the password and the hash. Okay. So to get a hash, we call in the library bcrypt. I installed it, right? And then bring it in up here. I'm gonna hash sync, passing the password and this number 12. What does that mean, that number 12? Well, 12 is the number of rounds as 2 to the 12. So it doesn't mean 12 times. It means whatever the number 2 to the 12 is, that's what that number is going to be. So a huge number, okay? So going from 8 to 12 is gonna add time. So the gist of it is, the higher the number, the more secure your hash is. And what's going on is under the covers, the library is gonna take the password, it's gonna add a random string to it, and then it's gonna hash it. And it's gonna get back a jarble string. But it's not gonna be enough. It's gonna take that resulting string that is nowhere near your password anymore, and it's going to hash it again. And it's gonna get a new string. And then it's gonna take that string and hash it again. And that's gonna happen 2 to the 12 times. By the time the library is done rehashing that string, that resulting string is gonna be really far from the original password, and that's the idea. So the higher the number, the more secure it is, but also the slower the process is going to be. So a good practice for you is to have a low number during development so that you can do your testing faster, but make it as large a number as you can in production without slowing down the process too much. So what can I do so that I could have that number change and I can use a number in development but use a different one in production? What can I do for that? An environment variable. So let's start by introducing them. I'm going to say const rounds. It's going to be equal to process.env that hash rounds. Okay. And if you don't provide a value there, I'm going to grab 8 as the default. So that is super fast. And instead here, we're going to say rounds. Okay. So over here, this is probably going to move now up here and say 8 as 2 to the 8th. All right, great. So now we have the rounds. We pass it in, taking in the password and passing it there. But again, if we do this, it fails. It says illegal argument undefined string. So it wanted a string and it got undefined. And it has to do with the hash sync method that we called. So someone says, yeah, it's because you're not passing anything in the headers. How can I protect my application? Because right now my server crashed. I just lost my server. So what can I do to protect my server in case there is an error? I want to capture that error and send back a message instead of crashing the server. That catch, okay. Only that catch works when you're using promises, and we are not. This is a synchronous operation here. If else, yes, you could use an if else check to make sure that you have the headers. That would be good validation practices. I still want to protect because maybe there is something else that goes wrong. Maybe the environment variable, there's a problem with it. Try catch. That's what I wanted to hear, right? So whenever you run into something that could potentially fail and drop your client, your server, you definitely want to use a try catch. So in this case, there are quite a few things that we could try for here. Let's just try for the whole thing and then catch any errors that we got. So try catch, all right? Any code that could fail goes into the try. So we're gonna put all this code in there. You don't really have to put the whole thing, but it's good. I mean, this is not gonna, hopefully not gonna fail, but just in case, I'm gonna try it. And then if we run into any errors here, we're gonna produce a response. This is the responsible way of handling this, right? 500.json, and then error, and let's send back an error, that message. That's not what you definitely want to do. You should probably want to have a nice message, but during development, we want to see if we run into an error, what does that look like when we see it? So right now my server is crashed. I mean, it would crash. Nodemon restarted it because I make some changes to it, but it was crashed before I restarted it. So let's go try it again. And now we get the error, but if you go back, your server never crashed. Your server has been running all along and it continues to provide services to other clients. So make it a good habit of anything that could fail like that. Try catch if it's synchronous. If it is asynchronous and you're doing promises, then of course you could use that catch there. All right, so how do I pass headers? Well, remember that underneath the URL here, there is a headers tab. And now I could pass in a password here, password. And just by having a password in there, it looks like what is our code doing? All it's doing is taking whatever you give it and giving it back to you. So it's not checking for anything. It's just grabbing the password and hashing it. So let's give it a password here. Melon, send that. And this is what we get back. This is our response. Like that. Okay, so let's call it again. And again, let's go check it out. Same password. Two different hashes. You see that? They're not the same hash, even though it's the same password though. So what's going on there? Library is helping you out by adding some randomness into the equation. How does that work? Well, if you're interested in security engineering work, you could go in there and see how they do it. For me, it's magic. It just works, right? So if you do have to store passwords, the correct way of doing it is by hashing it, not encryption, because hashing, at least we think, is a one-way process, okay? That's what we think. I don't know what attackers don't know, but, and a way that we slow down attacks, again, something called a rainbow table. I mean, it's a thing of the past, but it happens. Rainbow table attacks where attackers will pre-calculate hashes by just going through all possible combinations of characters and different configurations for libraries like this and pre-calculate those hashes. And they start saving them on the database. They've been doing that for years and years. So by slowing them down, you slow down the process of recalculating them. So in short, all you need to know is you should hash the passwords and you should have a big number for the rounds, as big as possible. And what is going to get stored in the database is going to look like this. Questions? Now, with this newfound knowledge of hashing, we can now change this to be probably a register endpoint instead. So inside of our API, we have these users. We can have, inside of the users router here, we can have a register endpoint /API/user/register. Or we could have a different area just for authentication, for login and all that. Well, up to you. Let's do it in here. I normally do it on an auth router. We could just do it here. We could have it registering here. So router.post. Then we have a register endpoint. Okay. The reason I don't like having that is because this gives me the problem now that I have to make sure that I organize my routes correctly and that I have this register before the checking a user by ID, so that it matches the register before going into the ID. This is gonna make it confusing. So let's go traditional. Let's have an auth router here. And then inside of this router, we're gonna have our endpoint. So let's copy the content of our user router. This is gonna use the user model as well. And it's got to step out of the auth folder, go into the users folder to grab the model. And then this is going to be a register, and it's going to be a post. So what we need to do for this endpoint is we need to bring in the library again. So let's go to the server, copy this, drop it up here, because now the encryption is going to happen in this file. Yeah, good question. How can we validate the password in the user login if we're adding all that randomness? Library takes care of it. You'll see when we do the login after the break, but it's taken care of for you by the library. Don't worry. So bcrypt.js, and now inside of the register, instead of define, we're going to do something else, right? We want to save a new user once we read the credentials. So const, we're going to bring the username and the password out of the body. Why is that? Because here you would validate the user credentials. Make sure the like things like check password length, make sure it's alphanumeric, etc. Right? Any validation, you want to do that there before you save it to the database so that you can produce a response. Okay. A good library to start working on validation, if you haven't checked out libraries yet for validation, it's one called Joy. So look at Joy for validation, play around with it. Actually, I probably should provide the actual link to the library instead, like that, not the search. Here we go. There's another one called Express Validator. This one uses middleware for that instead of validating schemas. Try them both, see what you like. Okay. Once you know the password and all, everything, whatever library, or if you're doing it by hand, once you know that everything is good, then you go ahead and go to the database. And this has an insert or an add. Okay, and it wants the user, information about the user. So the reason we destructured this is because we want to validate that stuff separately, the username and the password. But in here, you're going to pass the username and the password again together. You could pass rectal body. or you could call this credentials. Speak it and just pass the username and a password. What do we get back? I don't remember. Maybe a user. I don't know. You back and say data is the user. It was inserted. I don't know. I think you get a user back. We're gonna check that out, and this should be a 201. Okay. Any errors? We're gonna catch that and send back an object instead. That's an error, so that we can see it. So we have our auth router. Let's go back to the server now and bring it in. Moving super fast with this because you're kind of tired of doing this. So many times you've done it now. So I need to step out of the server, go into auth, bring in the router. Oh, come on, really? It's gonna make me type it. Okay, and now that we have it, we're gonna create a new endpoint, auth, and then we're gonna call this auth router. There. Say that. Now we should be good to go with the auth. Questions about anything so far? Do you think there's anything else that I need to do here? If you look at the code here on the left, is there anything that's missing from this side? What's missing? Something's missing. Well, no need for the try catch because we're using promises, right? So we have this that catch. Oh, server post? No, it's inside of a router. It should be router post. Look at the left. We're not hashing it. Yes. We are storing the password as plain text. Never store passwords as plain text, ever, okay? Always, always, always hash them. So we need this code over here. This is why we brought in the BigRip library. I thought that was a giveaway. All right, so we have the username and password, but we need to hash it, right? So const hash equals, and we're going to use the library. And by the way, the library has an asynchronous and a synchronous way of doing the password hashing. We're just using the hash sync because you still have to wait for it. And that way you don't have to do the whole callbacks or promises thing. So this is going to happen and it's going to block execution. So it's not going to continue until the hash is produced, okay? This is a part that if you think might fail, you might want to wrap that in the try catch, but not this part though. Hash sync, and then we're going to pass it the password. And again, we're going to bring in some, just going to copy this, a number of rounds that is going to make it slower for attackers to pre-generate hashes. So here we go. We pass that, and then we pass it the rounds. So we probably could now. All we need to do is say, hey, instead of the original password, I want to use the hash here for the password as we save the user to the database. So read the credentials, make sure you validate them, get the rounds for the environment, provide a default value during development, and then we hash it using hash sync, passing the number of rounds, and then we provide the hash as the password as we save the user to the database. Hopefully we get the user back. If not, we're gonna have to do some magic there, but let's go try it out. Duplicate. go to auth register, provide a body because this is going to be a post now. We want to use our name, Sam, and a password. Okay, definitely don't use pass, right? We want the password to be long and difficult. Hit that. Oh, this is cannot pause. Did I not use the right thing? Let's try. Slash registers slash API. Oh, did I do auth? Oh, slash API slash auth. There we go. It's right. It's telling me the truth. Uh-oh. 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 There's a problem here. It's taking a long time. Why is that? Who can help me work on this? There's a problem here. Ah, is the database running? I don't know. Is it there? Look, auth WEB32. The error is written wrong. Oh, error that message. This thing. Yeah, this is why we don't see the error. Let's try it so that we could see the error better. I forgot. Insert into users with these values. What did you just do? Get out. No such table users. What do? You need to, well, not see the database. What is this telling me? Migrate. Yes. What's the command? Connects. Migrate latest. Run that and try it. Excellent. And of course, we don't have a role, but that's fine because we're not passing a role. Let's create another one. Let's call gaffer. Pass and then pass it in a role so you see the difference. Role. And what goes into the role? Well, I don't know. Since I don't know, I'm going to go look for a place here inside the migrations. It wants the role to be an integer. Look at that. And it's pointing to this other roles table here. So since I don't have any roles inserted into a database, I'm going to do this. I'm going to say connects seed run. Boom. Okay. Oh, hey, no space. Why is there a space there? Here we go. So all tables truncated. It seeded the data for the roles. And I know that that's true. So I'm going to trust it because I wrote the thing. So now if I am adding a role, I'm going to add number 1 to the role for gaffer. And then we're going to do Sam. I'm going to add role number 2 for Sam. Here we go. Now we should have 2 users in the database, hopefully. So if we go to, if we duplicate this thing, we go to slash API slash users, we should have an endpoint that doesn't exist. So that's not the right endpoint, I guess. Slash API slash users. Oh, did I do a post? Oh yeah, I copied a post. Sorry, you're right. It's not a post. There we go. We have the gaffer and Sam. Here they are. Okay. So a lot of things happen there at the same time, but the most important one is this one right here. We created a couple of users. We passed a username and a password, and the hash, even though it's the same password, the hash for those 2 users is going to be different. Okay. Here they are. We don't see the passwords or the hashes. We never want to see those there. We could add the roles if we wanted to. But so far, okay, if you follow along with me after the break, not now, if you follow along with me, you're going to have a simple registration that all is missing is make sure that you have your validation. Let me close this because this is confusing. Okay, this is what we need. Rid of all that. Here we go. Question so far? That's the magic right there. The rest is just saving to the database. All right, so if you want to create an auth router like this one, so that you can complete it later as part of your project in the afternoon, here's the code. Okay. And make sure that you bring in your router from the server and that you're using the right endpoints. All right, so start thinking of questions and let's take a 5-minute break. And then when we come back, we'll answer any questions that you may have, but also we're gonna see how to persist that information using a session. See you in 5 minutes. And we're back. I'm just getting a head start on the boilerplate code for this. Questions before we go into the login and start talking about sessions. Have I used Passport.js? Oh, yes. Some time ago, though. Passport.js is a library that makes it probably the leading library still, I think, for using third-party authentication by passing different strategies. It's like a four-step, as far as I remember, it was like a four-step process. And if it works, it's great. If it fails, though, it's a little trickier to troubleshoot, but it's doable. I think let me show it because we're talking about a library without any context. Passport.js. This was really, really relevant when there where companies were not using third-party services for authentication and identity services. This was really relevant because you were doing that Google Auth and all that by yourself. So they have this concept of a strategy. So for every authentication type that you want to support, you need the library, but also you need the strategy for it, like local strategy, for instance, for username and password. If you want to use LinkedIn or Google or GitHub or Twitter, they have a whole bunch of them, and they have so many strategies, 502 strategies. So probably anything that you want to use for authentication, they already have a strategy for it. Okay. So it's not the easiest library to work with, but it's like 4 steps. Once you get those 4 steps, that's I find that the challenging portion of that is the providers themselves. Back then, when I had to use this, Facebook was like really hard to work with. Google was easy. Documentation is not as rich, but it's easy to use. Twitter was a delight, but Facebook was, yeah. Mhm. Because you have to go and create an account, and the process was a little cumbersome. I don't know if it's changed. That was a few years ago. I think this is less and less relevant now as people are instead using third-party services for that. So instead they use those libraries that are provided by the third-party services, but still a good thing if you want to go and check it out. The problem with Password for me is it goes into the realm of you rolling your own authentication, even if you're like, oh yeah, but I'm using third-party authentication now. I'm not starting username and password. Yeah, that's great, but you're still rolling your own though. So, but if you are going to do that, very good library. It's been around for a very long time, has a whole bunch of users. So, Passport.js. Let me just drop it in here. Back to the code. All right, so is that the only question that we have so far? Apparently, yes. Okay, great. So login. Login is you still have the concept of grabbing the credentials, right? But what we need now is instead of hashing the password, we're gonna validate the password coming in. So the model that we have for the database access has a find byte. Why? Because we have the username and the password. We're not looking, people do not provide an ID, they provide a username. So we have this method that we could call, and it will send a collection of users based on a filter. Find by is any filter. So what you get back is a collection. So out of that collection here of users, I'm grabbing the first element because I know that the username should be unique, like an ID. So if I get anything, I will only get one user, and it's going to be the first element of that array. So I'm grabbing that first element here, and I'm checking, do I have it? If I don't, I'm going to tell you, I'm not going to tell you, yeah, there's no user by that username. That would be revealing information. Instead, I'm going to tell you wrong credentials. I don't care. You have wrong credentials. So 401, it's actually unauthorized, but it's really not authenticated in our case. And we could probably send the message back. Don't kid around, use a real message there, okay? Now, if I found the user, That means you provided a good username and I found a user by that username. The next step would be, I need to validate the password. So user is exists and password is good. Yeah, so I don't want to confuse anybody here, but if you do a search on the users, you should be getting like a series of users back. So if you do a find by, you say, I'm trying to find users, and here's the filter. It's like you doing a select, right? And then you do where. And the where is some condition. And then you get a list of users back. So this is what you got here. You got a list of users. So in here, I'm going to say const user is going to be equal to, out of that user's collection, I only care about the first record. Done. Confusion gone. Okay. So the find by just takes any filter. I could pass it any other filter. I'm just saying, find me a user by the username. Now the username is unique. So if there is any response coming back, it's going to be a single user because that username is always going to be unique. So I can safely say, if there is a user there, it's going to be the first element of that array and the only element of that array coming back. Okay. Yeah. So all I did was take a shortcut and destructure the user out of that collection right away, but I don't want to be confusing. So one step at a time. So now that we have the user, okay, if the user exists and the password is good, here's the tricky part. How do I know that the password is good? Because you're going to send me a password, and then what I have in the database is a hash. And that's where the library comes in, right? We have this library that has a method. Can someone go real quick and check what is the method that we can use for that? Which method can we use to verify the password? There's a thread there. Ah, it compares. Great. Compare. It's got a couple of versions, the async and the sync. We're going to use the sync because that way you can stick it up here. I could say, oh, so the user exists and the password is good. I could do it right here. I could say, and we're going to use bcrypt, of course. Compare. I use the sync version of that. And the order matters here. Very important. The order matters. So the first thing that we get here is the string that we want to compare against the hash. So what goes here again? What can I put there? Oh, I see an example there. So I'm going to put the password there. So that's the string that the user is sending me. You could think of it as the password guess. They're guessing the password. And the second argument for that would be the hash. And the hash comes from the database. So I could go into the user and grab the password. Because remember, we store that hash as the password for the user. Now, this is going to result on a true or false. If they match, what the library is doing is taking the password, hashing it with the same information that it had before, and then comparing the hashes. But the point is that it does it magically. It grabs the hash from the database and the password that you have, and it tells you whether they match or not. And if they match, then you jump in here. Okay, so at this stage, we just send a good response back. So status of, let's say 200. Oh, no, not 300. That would be a redirect, and then send back a message. Maybe we want to send back, hello. Not hell, hello. Here we are. So the process of logging in, we're not using sessions yet. We need to first make sure that we can log in. So the process of logging in is finding the user on the database from the username so that we can get access to the hash, and then passing the hash and the guess to the library in the right order. So first the password, then the hash. That will return true or false. If true, and you have the user, and this is also true, then you're good to go. For now, we can try it. Let's see if this works. So duplicate the post. We care about the post this time. And it's going to be to login. Sam and pass. We don't need the role, so we're going to remove that there. And we're going to use a different password, 3 S's. We got, hey, you shall not pass. Wrong credentials. All right. If we use the right password, now, hello, Sam. That's great. And if we provide another username that doesn't exist, we should get the you shall not pass. And the idea is to keep on guessing. I don't know if it's the username or the password that's wrong. It's just bad credentials, okay? Question so far? Here's the secret sauce right there. Making sure that you're passing first the string, the regular string coming from the user, and then the hash from the database. I see some typing in there, so I'm waiting for the questions. Here's that code. I'm going to tell you what I think. I think authentication is not sexy. It's something that you want to get out of the way. Hence, we're giving you scaffolding with it. When you go to your labs project or any project, really, you want to get this out of the way. This is not going to be the main feature of your project. So use the lab scaffolding or create your own scaffolding with the company that you want to choose as your third-party provider. And if you want to use a library and do it yourself with Passport.js, create a template project, scaffolding project, save it on GitHub, keep it updated. And then every time you need to create a new project, you use that project as the template, base it on it so that you don't have to worry about authentication other than when you need to make changes to the way that you use it. This should not be the main focus of this week. The main focus of this week should be on unit testing and understanding the flow of I send credentials, get something back, a token or a cookie, and on every request later, I have to go, every time I need to access anything, I need to provide that identity in the form of a cookie or of a token so that the server knows who I am. Okay? Teams thinks that auth is sexy. So if the credentials are not correct, what would this return? I would read it on the documentation to see what it does. But in my mind, it returns a falsy value. Probably false. I have never really checked. But it will be true if they match it. I want to assume it's going to be false if they don't. But don't quote me on that, though. I would read it just in case. I know it's a falsy value, though, whatever that is. Otherwise false. It's a true Boolean, so true and false. Great, thank you. I knew that. I just wanted you to go read in the documentation. Sorry. All right. So what's the next step? Well, we talked about sessions. We just haven't done anything with it. And why are they important? Okay, I'll tell you why they're important. The whole idea of this is, remember, restricting access to an endpoint. So if we opened, let's go do this from the server side. If we go to the server, we have the users and we have auth. Everybody should be able to log in and register, so this is not going to be protected. But the users, I probably want to have it protected. So I'm going to call this protected thing, right? This is going to be some middleware. So let's go ahead and create a middleware file here, call it protected. And this is going to the protected middleware.js. Okay, great. Since it's going to be some middleware, it needs to return a function. So module dot exports is going to be equal to a function that has, did we decide on a name? The sisters is rec, res, and next, right? So this is going to be a middleware function. And what this middleware function should, in theory, do is it should check for check that the client is authenticated. So that is that it has logged in before. That's the whole point of this restricted middleware. So the question is, how can we check for that? Oof. Here's the problem that we have. When we log in, we don't have information about the user being logged in anywhere. Any ideas how can we implement this? What can we do? Yeah, we know about cookies, but before cookies, what can we do? Without knowing about cookies or tokens or anything like that, on the server side, is there a way that I could somehow check for anything here on that once they log in? Tricky, right? Yeah, exactly, right? It's kind of tricky, like, oof, how can I do that? Because they logged in, they make a request and they log in, and then they're gonna come back to the server. Ah, I need some, well, there are some things that you could do in Excel. Actually, you have locals, you could store something on the database, but that's not what we want, right? We want to give the client something that they could hold on to and keep with them, so that when they come back, they could remember that key card, that cookie. So this is where sessions come in. So let's go look at the library, because we could go around and dance with this, but ultimately you're gonna pick one of the two main methods, either using sessions or using tokens. So let's look at the library for sessions and see how that works. Express session. And then what I would say is, let's have you take 7 minutes again, read through this, and see if you can, let's take 5 minutes only, because it's a lot to read through. And see if you can find a place here where it talks about how to create a session. So we're gonna go exploring for 5 minutes. It's gonna take 5 minutes. So go into the Express session right here and see if you can explore a way of creating a session just in memory. Don't worry about databases or anything like that. See if you can find kind of the bare bones of how it works. Go. How did it go? Anybody got anything going? All right. We read some documentation. We took 5 minutes. We're not there yet. It takes longer than that. I know. Hey, we have something going on. So let's begin by bringing in, we're going to do this in the auth router when we do the login, right? We're going to save the session at that point. But turns out that to turn on sessions, this is middleware. So a really good place to turn on all the global middleware would be on the server. So we're going to come in here and say const session. It's going to be equal to require express session. Which reminds me, we need to install it. npm I express dash session. Here we go. So library installed correctly. Good. Now we have access to our session. This is middleware. And we want this middleware to run on every request that comes into the server. So we're going to do it, we're going to use it here as probably right, anywhere in here would be good. Let's do it right here. So we're going to say server.use, and I want to use session. Here's the thing though. We need to configure some stuff for this. So we need some configuration objects. So session configuration, okay? We're gonna pass it there. So we need to create that and have it somewhere. I'm gonna create it up here, const session configuration. Understand that the way that we organize our files during the presentations on the guided project is for convenience of learning, meaning the fact that you may see me use a middleware and write it in the same file, or that I have some configuration that I'm writing here in place, and it's got some hard-coded values that you should probably be reading from the environment, only means that it's easier while you are learning to see everything together on a single file. Later, as you start building, you'll notice you'll be like, this is not a good idea. This should come from an environment variable, or this should be in a configuration file somewhere. Yes, it's okay. That means that you're moving into a more production-ready code base. But for now, don't take the fact that we're kind of cramming a lot of stuff in a single file as an indication of this is how you architect your solutions. Okay, keep that in mind, please. So with that said, let's create a configuration object in here. And if you read through the documentation, you'll be like, how can I possibly go through all of this? Yes, of course you can't. I just wanted to get you into the feeling of reading the docs. Okay, but there are some bare bones configurations that we need to address. So remember that the flow is someone comes in and we're going to save a session for them. Okay, save a session. The next one reveals the rest. Okay, you log in. Okay, going to validate the credentials. We saw that. Then we're going to create a session and produce a cookie. We want to do those two things. The library, this is outside of our code. The library is going to do that. Cool. So we need to help the library a little bit. The cookie, I don't know if you've seen where the cookies are. Yeah, I think you've seen where the cookies are stored, right? If you probably did that. Let me see if there are any cookies that I can show you here. So inside of the network application tab, sorry, there is a cookies section. If you expand that, you'll see that there are cookies there. I think we saw those before. That's where they're stored. The browser stores them. And you can choose whether you want to let JavaScript have access to those cookies or not. So those are part of the configurations. Those cookies have a name, okay? So one property that you might want to change is the name. You want to give it a different name. So we're going to call it monster because this is the cookie monster, okay? Or the monster cookie. And then you need a secret. And this secret is because the library is going to try to encrypt that information instead of just showing it out there. it's going to encrypt it, and you need a secret for that. So, okay. All right. So that's the second value. The third one is some information about the cookie. The cookies are not eternal, okay? We have to restrict the duration or the validity of the cookie. So let's record some information about how do we configure those cookies. The first one for sure is going to be the max age. And the point here is in milliseconds, we're going to tell it. So it's going to be milliseconds. I'm not going to do any math. This would be a minute, and maybe 10 minutes should be good enough. Not really. You probably need more time. But for development purposes, we're going to say, yeah, it's good for 10 minutes. After 10 minutes, you need to get a new one. The cookie expires. Some systems will go for weeks without expiring the cookie. Depending on your security settings, this could change. So don't try to make that decision now, just wait. And then there's this secure, and we're going to set this thing to false during development. So I'm going to say process.env cookie secure. Okay. And if I don't have a value for that during development, I'm going to say false. Okay. And the whole idea is if true, cookie is only sent over HTTPS, meaning an encrypted version of the HTTP, the secure version. It should be true in production. You should not be sending authentication cookies over an unsecure connection, ever, even if they're encrypted. Questions there? Is it a standard name that companies? No. I think you should make it something weird so that people don't know that that's the session cookie, as a way to kind of obfuscate the fact that if they grab that cookie and they take that, they can work on decrypting the value offline to get at your authentication cookie. For sure, keep it weird. Don't name it. Don't name it monkey, for sure. Does the HTTP only property, can someone check on the docs, does the HTTP only property goes inside of the cookie object or outside of it? I can't remember. I'm gonna go on a limb here and do HTTP only here. True. And what this means is JS cannot touch this cookie. Can't see it, can't read it, you don't want to, because the browser will send that cookie automatically on every request. There is no reason why JavaScript would be touching that cookie at all. And then the rest of the information, of course, is about the session. There's a resave option. You probably want to have that false. It's about if there are no changes to the session, do you want me to still kind of resave it? Probably not. I don't know. That some companies have different feelings about this. Save on initialize is if the cookie, if there is no please read about GDPR and read about this on the documentation for the library. But this is needed for GDPR compliance. So normally what happens is the client will have some kind of UI that shows the user that says, hey, are you okay me saving cookies for you? And if the user says no, then they will send a request to the server saying, hey, please do not save cookies for this. I'm providing a value, says, don't save cookies, or save cookies, false. So you should be relying, when the user log in, you should be relying on that value and storing that value so that you know whether that user wants, and it could be part of their, it could be stored on their database record, on their profile. You have a database with the user. When they log in, they make that choice. They tell you no, and then you set that setting and you read that setting for that user. Okay. If it's not a logged in user, then you just store it on a cookie. You can produce cookie. There is a cookie parser library. There's quite a few cookies libraries. So you could produce a cookie for that, and then just make sure that you save that information there for the user. But the point is, if the user doesn't want any cookies, they will let you know. The client should let you know by sending you that information. For now, I'm going to assume false. Actually, I'm going to do true because I want to create it. But this is during development. The client should drive this. Follow your guidelines on the company you work for about how they handle this, where they store that information, how they handle it. But that should be a preference coming from the client. You don't make that decision yourself, okay? Now, by default, the library is gonna save the session information to memory, meaning it's gonna be in memory, so if the server restarts, the information is lost. Is that a more persistent way of saving data so that it doesn't disappear whenever you restart the server? Why would we want that secure value to ever be false? Or to ever be true? What do you mean? Oh, did I? What do you mean? If like in production, never, ever. We do have a false on development though, because we don't have an HTTPS connection with certificates and all that. But in production, I can't think of a reason why you would ever want to have that be false in production. But that's an opinion. I would never have it be, false. So if the user says no to cookies, how do you keep track of their session? You don't. You don't. This is why good implementations of cookies have more information, and they tell you, hey, if you don't accept cookies, some of the functionality of the website will be broken, of the web application will be broken. Sessions is one of those. I mean, you can manually send other headers, you can manually send information, but normally you tell the user, it's gonna break the site if you don't accept cookies. The best I don't have the link now, but the best implementation of cookies I've seen, they actually had options. They would say, save only cookies for authentication, and they will tell you for advertising, for what, but the core functionality like authentication, they let you choose for that and not for the rest, which is great. Not every company does that though. They want to give you if you want to use it, you have to accept all cookies so that we could bleed your eyes with ads. So yeah. Okay, so going back to how do we store this? Cookies are normally stored in a key value store like Redis or Memcache. We established that. But for now, we don't have that. We don't want to have yet another server running for testing, so we're just going to use the database. So I want to tell my library, hey, store the information in my existing database by using connects. For that, we're going to go to the docs. Because it turns out that if you scroll down, all the way down, it's a big list here of all the compatible session stores. This library has been around for a bit, and look at all the stores that you have in there. Up in that list somewhere, there is a library that you could use to connect using connects. If you are using anything else, any other way of using accessing the database, check in there. It's a really high chance that they support it. But the library that we're looking for is called Connect Session Connects, I think. Here we go. This is the library. So we're going to install that. You can go ahead and run that. So now that we know that we not only need express session, but if we want to store in the database using connects, we need another library that will connect those two worlds. It's going to be like one library is in charge of dealing with the sessions and the cookies, but then it delegates the storing the data outside of memory into another medium, like the database or a key value store, to another library. And now you detach the two things. If you ever need to change the way that you store data because you changed to using maybe Redis, now you just bring in another kind. You could think of it as the driver for Connect. Remember that you have the library and then you have another thing that says, depending on what you're targeting as the data store, I'm going to change. So that's what this library is going to be doing for you. Now we're going to bring it up here. And this is a little tricky to use. So it's a good thing that you're going to have a scaffolding for this. Connects session store. We're going to give it that name. I name it this way because it's a constructor function. This is what you get out of this thing. And this needs to do some currying. Do you remember currying? Where did you use currying before? Anybody remember? When you did something like this. Redux. Connecting components, the connect function, yes. So when you require this package, you get a function back. And the function needs to talk to the session. So you pass it the session, your library, to it. And then after you do all this, you get back a constructor function. So since this is a constructor function, you can't just use it. You have to new it up to get you think of it as a class. And then you get an instance of that class. And that's what we're going to use here. So store, I'm going to say new connect session store, and then we're going to pass it some configuration. Still with me? Do you have to write all this? No, I'm gonna give you this configuration file code. Okay, I want you to instead ask question, kind of follow the flow. All right. So what does it need to know? Well, it needs to know, can you give me a connection to the database? Turns out that we do have that. So we could come in here and say cons db connection. It's going to be equal to require. What's the file that we normally have? Like if we were looking for the file here, what's the file that we normally have that describes a way to connect to the database that we can then use to talk to the database directly? The db-config, that's right. So if we look inside of the database, there is a connection.js file. We renamed it here to make it a little clear that this is the connection. So we're inside of this server. We're going to step out, go into the database folder and grab the connection file from there. But if you go look at that connection file, it's similar, a little more dynamic, but it's similar to the db-config file. Okay. So this is my database connection, and the key for that is connects. So we're going to pass it that version of connects. Remember that the connection file is going to have a version of connects, but this version of connects that you pass it already knows how to connect to it by reading from the environment. This is using development as default. So that's the first key for this. And then it's going to ask you things like, okay, so you give me a database. What is going to be the name of the table? And you can pass it a table name. I'm going to call it sessions. And also, what is going to be the kind of the primary key? They call it like session ID. So it's going to be seed field name. So that's the name of the column where you want to have the session ID stored. Normally we do seed. I think that's the default too, but it's good to have it there. The other thing is you probably have a database that doesn't have that table. Do you want me to create the table? And I'll be like, yes, please go and create the table if it's not there. So if the table exists, it's going to use it. If it doesn't, it's just going to create a table for you. And the other part of that is you just told me that the cookies, and this is tied also to the session, that the sessions can expire every 10 minutes, every hour, every 10 days. I don't care. The point is, what should I do when a session expires? Do I keep it on the database? If so, that's going to grow super large. So it turns out that there's a clear functionality for this where it will just go through the table and be like, okay, anything that is expired, gone. And it will clear the database for you, keep the database tidy. And it asks for an interval for that. And that interval is going to be milliseconds too. So you could be like, if you have the math, like use it, right? But if not, just you could probably do an operation like that. So this would be a second, a minute, I guess, right? So this is a second, this is a minute, and then this would be an hour. Like every hour, go and clean up the database and just delete any expired sessions in there. So basically this is delete expire sessions every hour to keep the database smaller. Oof, that's a lot. And we're not even dealing with all the configuration that you could pass to this library, okay? But that is it, I think. Okay, this is going to give us a session object whenever we log in. So let's go back to our router. And when we send back the user right here, hello username, I'm also going to send back session, reg-session, and see what's in there. There should be something in this session, hopefully. Before we do that though, I am going to come into my server and disable the use of sessions. Save that. And log in. Is this the login? Yes, this is the login. Oh, connection refused. API auth login. What did I break now? What did you break? Oh, look at that. There's an error somewhere in here. Protected is not defined. Oh yeah. Did I keep that? Yes. I did. So let's get rid of this for now. You're not using it yet, anyways. So let's try that. Started the conversation and forgot about it. Hello, Sam. Oh, no session. Look at that, right? We only get the hello, Sam. There's no session. Now let's go turn it in. Turn it on. Turn it on. Now we have sessions. Do the same thing. Ah, ha, ha. That's what we wanted to see, right? We have hello, Sam. And then we have this session object and information about how the cookie is configured. That's all in there. Here's the original max age. This is when it's supposed to expire. Secure HTTP, and then this path, it's I don't know how that works. So what does that tell us? It tells us that when you turn on the library, it's going to save some information to your database, and every time someone logs in, you have a reg-session object that now you can use. That was our problem. Our problem was, okay, they log in. I need a place where I could save some information about that user so that I can then check later on my middleware. So the server portion is already done. Let me give you this file. So but that's good. You're gonna get the code, but I want you to test it before we go, just in case. But then let's go work on the middleware. How can I restrict access now? I know that we have a reg-session, okay? And we can put information in that reg-session. So on login here, we're gonna save something and we can check for that here. It could be as simple as a flag. It could be information, richer information, like maybe more information about the user. So I'm gonna say, as part of the checking of this, during the middleware, I'm gonna assume that there is some information that I can check. I'm gonna say if reg-session and reg-session dot, let's make it simple. Say logged in. If that is true, then I'm gonna call next. Otherwise, there's that status 401, and remember, you shall not pass. Okay. Now we need this value on the session though. So a good place to do that is both on the register and on the login before you produce a response, right? Right here, we can set that value. Say rec that session that logged in equals true. Now, where, this is critical that we understand this. Where is the logged in Boolean saved? The cookie? What do you think? Type your answers there. Think of it for a minute. If I open up the cookie, does it have inside of that cookie, will it have the logged in property? Not in the cookie. That is correct. Yes. Remember, it's saved in the session. So all of the information that you add to the regda session object is persisted to the database now, to that table. It never makes it to the client. It's never inside of the cookie. The only thing inside that cookie is the session ID. All of the other data is kept in the server, okay? What can you add to that? It's a JavaScript object. You could add anything. You could add the username, the password, preferences, any information that you need, you could save it to the session. The cookie itself is just gonna have an ID so that when the library needs to go and look at the session information, or if you read information from the session, that's gonna be reading it directly from the database, from that table. So when we read over here, and we say, hey, rec that session that logged in, and we read that, we're reading it from the database, from the actual server database. Remember that because that's one of the main differences with using tokens. Sessions require some storage on the server, and all the data that you save inside the sessions is stored in the server. So what is a cookie? It's a container of data. It's just a little object that travels back and forward between the client and the server, and it's going to save some data in there. In fact, there is a limit. It can hold 4Ks. That's all it can hold. So the cookie is not a session. The cookie is not for authentication. The cookie is a way for you to store a little bit of information so that it can travel between the client and the server. And the browser specifically has a special place where it saves cookies, separate from everything else. And you can have cookies that JavaScript can modify and access, but you can have cookies where you tell the browser, this is just for you, JavaScript cannot see them. Authentication cookies should be protected from JavaScript. But I trust my JavaScript code. Yes, but some people have extensions on their browser. And those extensions, guess what? They run JavaScript on your browser. So whenever you add an extension to your browser, yeah, you're bringing in some weird JavaScript code that someone else wrote. It may not be weird. It may be good JavaScript code. But don't trust extensions. They are executing code in your browser. And if you have anything that can be accessed from JavaScript, those extensions, hey, be careful. So session stored on a table on the server. It could be memory, but we chose to configure that using connects to connect to our database and create a sessions table in there. Is that true though? I don't know. Let's go open SQLite. Let me show you. Let's open it up. And Command O, find that folder. Side of the WEB32. This would be sessions database. You can't see anything, I know. So sad. Here we go. Now you can see it. So here's our auth table, and look, there's a sessions table in there. And if you open it, you'll see that it's got some columns. The SID, the session information, this is going to be a long string, and then expiration information about it. And if we double click on the table and we look at the data, look, we have a session ID that was generated automatically, and here's the information about the session, the cookie, original, all of that data in there. And here's the expired date. It's a separate thing so that you don't have to unwrap all this information to get it. So when the library is making the clear and it's deleting, it is actually a date. It could say, hey, delete everything that is expired from now, anything before now that expired, delete it. So here's where all the data is, right there. See all the expires, the original max age, all of that data that you saw is actually stored in the database in that object there. Okay. Questions? That's it. If you don't have any questions for today, I'm going to do one more run and that is it. Now you can go work in the afternoon. Any extra time you have, please use it to review the content for the past couple of weeks. A good exercise would be to take a blank repository and see if you can do, create the migrations for the username and the password, and see if you can implement everything but from scratch. Do your configuration, create your databases and all that. Practice it a little bit. Even that find by function, see if you can write it without looking at the code. So again, going back to the first thing, you have headers and body. We read the credentials from the body, but the cookie and some information like, we'll use the headers more tomorrow, but you can also bring information from the headers. And that's what it looks like, it's a kind of a review of a simple HTTP message. So when dealing with authentication, the client is going to send some credentials to your API. Your API on login is also on register. It's going to save a session to some kind of store. This could be a database, or it could be something like Redis or Memcache. Those are separate servers. Remember that. So if you want to have those things running, and it's like another database server that you have to manage. Okay, there is a drawback to that. The most common way of storing session information is in one of those servers. Okay. And each client is going to get its own separate session, even if it's the same user. Very important, okay? Anything that you store inside of that session object that gets created by the library is going to be saved on the database itself, not on the cookie, okay? So if we reveal a little more of that, we'll see that the client logs in, the API validates the credentials, creates a session, produces a cookie, and sends it back with the help of the libraries. And then the client will automatically send any cookie associated with a particular domain. This is going to have, you don't have to do anything. Notice that we didn't do anything on the client. Your React application is going to be the same. If you're using cookies, React doesn't have to do anything. You just send your request and it's going to happen for you on the browser. The browser does it. It's going to grab that cookie, attach it to the request. It's going to send it back. That cookie has the session ID, and that's how the library can take the session ID, go into the database and say, is the session expired, and do all the magic to get you the data that you need from the session. We use that on a piece of middleware to restrict an area. We haven't set up the middleware though. We have to set it up. So let's bring it in. I don't think I have it here. Nope. I'm going to say const protected. It's going to be equal to require, because we didn't really show you that. We just wrote it. And then go into the auth and grab that protected middleware. There we go. Now that we have it, we could bring it down, and in the user's router, use the protected, like so. Okay. So if we go back and we go into the users, we're using the protected method where you shall not pass because we're not logged in. How do we know? Well, there's no cookies. We don't have any cookies. We shouldn't have any cookies, at least. I think we had cookies from before, yeah, but this is not a good cookie. It's already expired. But if we go ahead and log in, we're gonna get a new cookie. There you go. So now that we have, you can look at our cookies, we have the monster cookie here. Now that we have a new cookie that is good, we could go there and hopefully hit send and go to the response, the body, and now we get the users. Instead of getting the you shall not pass, our cookie, we just got a new cookie that is good for 10 minutes, and now we get access. So what happens on logout? That's the last thing, okay? So the last thing that we do today is implement logout. So logout means invalidating the session. And since the session happens on the server, we need an endpoint for that. And you could create an endpoint anywhere. Let's do it on the, I don't know, the auth router. Let's do a router dot. This could be even a get because you're not sending any information. You're saying, I just want to do a logout. It could be a delete too. So let's do logout. And look, it's super simple because the library has a destroy method that you could call in the session. So you could, in theory, just do this, rec, ooh, rec that session dot logout, sorry, destroy. The problem is if by any accident, someone makes a request and you don't have a session object, I like to check for that. So normally I just say, and JavaScript has newer features now. We could, it's not out yet, but we're not gonna need to do this anymore. Once those features roll out, we could have things that are kind of, it could be undefined, and yeah, I'm excited for that. Anyways, for now we don't have them, so we don't have to check. I'm gonna say, do we have a session, right? If I do, then we're gonna call this. And else, if there was no session, you could send a message. And this could be a 200, right? And be like, yeah, already logged out. Or something like that, right? And then once you log out, again, this should not fail, but just in case it fails, you can actually pass a callback function to it. And in the callback function, the first parameter would be an error if there is any error. So you can also do that. You can check that there was an error before you continue, right? So when you call destroy, there could be an error here. And if there is an error, you could check if I have an error, then I'm gonna send a message, else, that means everything is good. So rest that status. Maybe you wanna do it 204 and send nothing because it's just logging out, and then just end, right? 204, it means no content, right? We've seen that before. And if we do have an error, maybe we wanna send back a 500. Saying something happened in the server, we could not log you out. You can check out anytime you like, but you can never leave. That would be creepy, right? But it could happen. So again, on logout, we no longer care about you having the wristband or having the card or having a cookie. We don't care. We control whether you have access or not. It's not about the cookie or the wristband. It's about, are you still a guest? That is a valid guest in the hotel, right? So the library reserves the record. It gives you the power for you to destroy that session at any time. And you could do this for different reasons. This is, because the client wants to log out, but it could be because you decided, there was a breach and you go and log everybody out. You could definitely go just clear a particular session or clear all the sessions. So how do you log out if either for max amount of time? You have to write code for that. Yep. Have to write code. It could be running on the server, or it could be running on the client. But you have to. The message that you see pop up, like when you go to the bank, that is a timer that they are writing on their application on the client. That's not probably coming from the server. You remember that you have things like intervals, but also there's another one called set timeout, where you could say, hey, we have this set timeout of, I don't know, 3 minutes. And in 3 minutes, I want you to go and execute this function. And what this function does is it's going to show a message for, I don't know, 30 seconds. And then after that, boom, it's going to hit the server and do a logout. But you have to write. The library doesn't, there's no way for the library on the server to know, hey, yeah, you have to write some code for that. And what you do is every time they do an operation, you reset that timeout. I wonder if there are libraries for that. Probably do. Probably 200 of them. That's it. That's it for today. If you have any more questions, please reach out on Slack, and I'll send you the code in a minute. And please use this time to practice. This is the last push. And I'll see you tomorrow. Have a good one. Glad you're still here.